just continuing off from where we left off in class. I highlighted the answers in a different color now. So we're looking at this scenario here. If we have two lines, A, B, and LM, two pairs of lines that could be potentially parallel to each other. And we got to prove that they're parallel given this information. So let's say that 12 and 14 are congruent. We know they're congruent, okay? And we have to prove now that where the lines they belong to, which is over here, and here it could be AB or LM, which two, them being congruent, using one of these theorems over here for the converse theorems that we're talking about. These are, if let's say that this is alternate exterior angles. If these two are on the outside, they're alternating, okay, like one over here and then one on the other side of this line on the transversal, and they're on the outside. If they are parallel, or if they are congruent, that proves that lines P and Q are parallel. And then same case over here, if the interior and the ones that are right next to each other are congruent, then that proves that by the consecutive interiors angles converse theorem, that then these two lines will be parallel, okay, which is kind of opposite from what we've learned in 5-5 as we were going through in class, okay? So this is just a reiteration of what we've been kind of talking about in class. So let's take a look at it. 12 and 14 seem like they belong to A and B, and they're connected by this transversal, okay? So 12 and 14 being congruent, what does that look like? Well, it looks like they're not corresponding. 12 corresponds to 16 on these sets of angles made by lines A and B separated by this M transversal, okay? So they're not corresponding. 12 and 14 are not corresponding. They are alternating. It seems like one is on the bottom and the other one seems to be on the top, so that's good. And if we look at our converse theorems over here, we're down to two alternating types. They could be on the outside of the exterior or on the inside. If they're alternating interior on the inside of the two parallel lines and the transversal, then we would say that they're alternating interior angles converse. Or if they're on the outside, we'd call it the alternating exterior angles converse. Let's take a look one more time. So I think first things first is we got to say which lines. I'm going to do it in a different colored pen. Shoot. Okay, there it is. I'm going to say the lines. Which lines do I think are being proven parallel with these two being congruent? And I'm going to say that's A and B, the lines A and B. A is parallel to B. I'm sorry, that's supposed to be two separate lines kind of diagonally drawn. And then I'm going to say it's the converse of the alternating, and it looks like 12 and 14 are not interior. They're not on the inside of these two sets of angles. So I'm going to say that they're on the outside, the exterior. So that's the converse alternating exterior angles. That's the theorem that proves that A and B are going to be, the lines A and B are going to be parallel because 12 and 14 are related as such, and they will make those two lines parallel. How about 1 and 15? Angle 1 and 15. Let's go over here. 1 and 15. Ooh, very tricky because it seems like they're on. Well, it looks like I would say, let's see. It looks like they're comparing. I know it looks really tricky here. 1 and 15. Oh, actually, this is a really tricky one. Actually, I'm trying to figure this out right now. Oh, well, let's see. I'm going to say that 1:15. It looks like they're on the exterior. Okay, and they're alternating. Looks like this is kind of going up and down. And then I say, okay, up and down. I'm going to say it's line L and M that are trying to be. But then I ask, what's the transversal between L and M? How about B? Oh, it looks like 15 would be exterior to 5, but what about 1? Wait a minute. Is this the transversal? If L and M are separated with this transversal, then 1 should be exterior, alternating exterior to 11. But again, that's not 15. We're worried about 15. Huh. How about if we try like from this angle? This is exterior to this, alternating exterior. And then let's make, what was I trying to, so I tried proving that these two lines were parallel. Let's try to prove if A and B are parallel. What's the transversal between 1 and 15? Let's say L. Wait a minute. Again, 1 would be alternating exterior with 7, so that's not the transversal. So we're trying to prove again L and M are parallel. Let's try, let's try, I think we're saying A and B are trying to be parallel, I'm sorry. And let's say M is the transverse. Again, 1 is exterior to 11 if we're talking about, let me see, I'm sorry, I'm getting confused here. I'm getting super confused. Okay. How about so A and B we're trying to be parallel. A and B are trying to be parallel. And I would say on B, this would be the exterior angle. And I'm going to say this is the transversal. Wait a minute. If this was the transversal, then 15 is exterior and alternating with 9. So you know what, guys? It might happen. This is not possible. There are no possible parallel lines. That is meant to trick you. That is actually the answer for D. There's no lines that can be proven are parallel with these two. I mean, you can do it. You could be like, oh, this is vertical to this, which is this. Like this connects because this is a interior. What is it? Converse, or is it a congruent or a corresponding interior? And then this is corresponding interior, and this is vertical. You can prove it many ways, but we're saying with just one of the Converse theorems in here, can we prove it just by only this given information? 1 and 15 are congruent. Can we link that fact up with one of these singular Converse theorems to say that any of these lines are a group of parallel lines? And we say no. Not just, but we can make many connections to get to that answer. Okay. I know you guys are already kind of thinking about it, but that's not what I'm asking. Okay. Just asking if you can determine one with just one postulate and that singular connection of 1 being congruent to 15. And that's it. You can't make any other connections. That'd be it. Oh, nice. Okay. So that was a tricky one. And I meant to say that that's congruent. Negative or angle 1 is congruent to angle 15. Let's try angle 8 and angle 13. Okay. Those are adding up to 180. And to me, it looks as though, I know it's really tricky to see, but what I see is that they're on the interior. They are consecutive. They're not alternating. What alternating would be 8 and 14, but 8 is right next to 13. So 8 and 13 add up to 180. That's good. That means they're supplementary. And I think that it's trying to prove that L and M are the lines that we're focusing on, and the transversal would be B. So in this case, L and M, they're on the interior. They're consecutive. It's one after the other, 8, then 13. And they add up to 180. Let's see if there's anything that says such a fact. The consecutive interior angles theorem, I think it's this one here. It's not alternating interior angles. It's consecutive interior angles. Converse says that if two lines in a plane are cut by transversal so that a pair of consecutive interior angles is supplementary, meaning they add up to 180, then those lines are parallel. Such as, if you can prove that if 4 and 5 are for sure going to add up to 180, then that makes P and Q parallel. Let's check this out over here. It even says on part E that if measure of angle 8 plus the measure of angle 13 is equal to 180, let's see, 8 and 13 adding up to 180, they're consecutive, they're in the interior, and they make L and M. I think they make L and M parallel, and then we would use the converse. What is it? Interior. Let's see. Converse. I'm going to say consecutive. I'm going to abbreviate that. Consecutive interior angles. The last one is angle 8 is congruent to angle 6. Okay, let's look at that. Oops. Okay, and does it prove? So I think that's great. They're vertical angles. I think they're congruent to each other, but does that prove that two lines are parallel to each other? They belong in the same set of angles. So normally we need at least two sets, like 5, 6, 7, 8, and maybe comparable 13, 14, 15, 16, or 5, 6, 7, 8, and maybe 1, 2, 3, 4, or I don't know. I just find that it's in the same set of angles. They're vertically to each other. And that's not, what is that going to prove to me? That's going to prove like what B and L are parallel. That's not true. They're intersecting. Parallel lines do not intersect, if you haven't noticed by now. It doesn't prove that A and B are parallel because none of those angles belong to A or A, they belong entirely to B. And if I say L and M, then I know that these angles, there's none of those angles, 8 and 6, are even associated with the line M. So this is not possible. Even though they're vertical angles, I get that. It's not telling me anything about two lines that might be parallel to each other. Okay? Okay, so that's very good. We're going to do one more example, and this is the last example. Which of the following facts would be sufficient to prove that if line D, so this is line D, so take a look at this, line D is straight across, is parallel to line XZ. So you know what? My suggestion is to maybe continue this line so it's better easily, you can see a little bit easier that this line and this line are supposedly supposed to be parallel. But what would prove that? Which of these statements would prove that? Let's say 1 and 3. So let's see, if angle 1 was congruent to angle 3, let's see if we can make any connections here. Again, those angles aren't really touching or on the other line, but let's see. Angle 1 is congruent to angle 3. And does it relate anything to this? I think angle 3 is corresponding to angle Z. No, not. So I'd say no, that doesn't really work. Angle 3, or actually, maybe it's better if I just tell you it. Okay, well, okay. Let's take a look here. Angle 3 is congruent to angle Z, this inner angle. I like this so far because what would also help too is to kind of visually see, if I extended this line, that you have a transversal. These are transversals. I know these because these are not in any way parallel to each other. And they're definitely not parallel to these two existing lines, XZ and D. And also the guys we're trying to focus on are D and XZ anyways. And hopefully it better shows you some exterior interior lines. So Z, I'm sorry to draw this, but Z, let's make this a little bit easier to see. That's angle 3, that's angle Z right here. I think that they're on the interior. They're on the interior here. They're also alternating. So they should be congruent. And if they are congruent, so I would say that lines, what is it? Line XZ is congruent, or not congruent, parallel to line D, because I think it's the converse of, the alternating interior angles, which is this one right here. The alternating interior angles converse. Okay, that's actually the answer B. But let's take a look at why the other ones don't work. So I've already talked about 1 and 3. 1 and 3 doesn't do any connections straight from this to this guy. And I can't make any relationships like this is, this is vertical to him, and I don't know how he is going to be associated with him in any way. So there's nothing here. So there's nothing there. Okay, how about 1 and Z? That looks pretty good. Let's see, 1 and Z. Well, let's see, what's the transversal there? They're not even linked by the same transversal. This is the transversal right here, right? But if I want to make any relationships to that guy, to this transversal on these two lines, all the angles that I would need are going to be like in 2 and 3, Z, and whatever's on this other side. 1 I can't really make a relationship with, and 1 is associated more with this transversal. So I can't figure out anything that makes these link. It looks like they're alternate interior. Okay, but again, Z is kind of more associated with this transversal, and 1 is associated with this transversal. So they're not truly alternating interior angles, because even though they're both touching the parallel lines I want to look at, they're created using different transversals. So C does not work. Okay, I can't find anything that talks about linking two angles that are on different transversals. Okay, it has nothing to do with that. It's usually these converse theorems are with two parallel lines in a transversal. Okay. Last one is Z is congruent to X. Sorry, that is angle. Oh, is that 2? Yeah, I believe that might be 2. Let me look back on the problem here that I grabbed from the book. So this is in your book. Okay, yeah, so sorry. That is angle 2. So let's look at angle 2 and Z. Whoa, that's pretty good. Angle 2 and Z. It's looking pretty good right now. Because remember, I'm looking at these two lines being possibly parallel. And they are on the same transversal. And I said that angle 2 and angle Z, they are on the interior and they're consecutive. But wait a minute, it says that these two are congruent to each other. Is that what I want? So let's look at what the consecutive interior angles converse says. I like the outlook of this guy. It says if two lines are in a plane are cut by transversal, looks like P and Q are cut by that transversal, okay? And a pair of consecutive interior angles right there, 4 and 5, they're not alternating. 4 is not here and 5 is not down there. It's not alternating, it's consecutive. It's just 4 and 5, like kind of on the same side of the transversal. So that a pair of interior angles is supplementary. So they must add up to 180. 4 and 5 plus each other. When you add 4 and 5, angles 4 and 5, the measures, they should be 180. Then the lines are parallel. But does it say that? Does it say the angle 2 plus angle? Oh, you know what? I made a mistake here. It's supposed to be these two here. But even so, let's take a look. Okay, so sorry about that, guys. Super mistake here. Angle 2 and angle X. I jumped the gun. But let's say, let's see, angle X, I guess, would be created using, let's see, I guess this is angle X right here. Okay. So, same kind of thing, though. What is it? Let's see. Oh, this one's even trickier. I can't even make a good relationship between 2 and X because let's say we're trying to make these two lines parallel. And we could say that they're consecutive interior angles, but they're not because the consecutive interior angles with D and this line, XZ, we would be talking about these guys. 2 and 3 and X. We could say that 2, 3, this angle 2 and 3, this combination of 2 and 3 plus X is 180, making them supplementary, and then alternate, or they would be interior angles, consecutive interior angles that add up to 180. That's definitely not what this says. And in fact, it doesn't even include angle 3. And we don't even know if Z and X are congruent. It doesn't give us any information to tell us they're congruent. We don't know any theorems that say they're congruent. And what is it? That wouldn't tell us anything if they were congruent. Because if they were congruent, then what Converse theorem tells us that that's going to be important? So no. So the only answer that I can come up with is B. And that's what your book has as well. Okay, guys. That's pretty much everything I have theoretically for this section. There are some other problems here, but otherwise all the problems are pretty much the same or very similar to the ones in 5-5 that you've seen before. Okay, guys. That's it. You guys have a great weekend. Good luck. Bye.